Hi students, in this video I am going to explain you the problems of exercise 5.2 of differentiability. See, there are 10 problems here. Let us see. The first one, d by dx of sine. Here we need to apply the chain rule. How to apply the chain rule I will tell you. See, we don't know the actual derivative formula of this, but we know the derivative of sine x. So we treat this thing we assume as sine x. So d by dx of sine x, take it as x. It will be cos x into d by dx of the thing whatever we assume as x. What we are assuming as x? So this thing. Now it will keep on going like this. Into derivative of this is 2x plus 0. And you write this thing here beside cos, or otherwise you may get confused and you may take this 2x inside this cos. So this is the way of writing this problem. Suppose in the second question, d by dx of cos of sine x. We know the derivative of cos x, we know the derivative of sine x, but we don't know the derivative of cos of sine x. So we assume something as x. See, assuming something as x and again taking the derivative is called the chain rule. Okay, now what should be assumed as x? So this thing we assume as x. So cos x, derivative of cos x is, see in the list of formulas, it will be sine x, here x is this, into d by dx of the thing which we assume as x. So it becomes minus sine of sine x into cos x. Okay, suppose in the form, third question, d by dx of sine of ax plus b, So we know the derivative of sine x, but we don't know the derivative of sine of ax plus b. So we assume this thing as x, sine x. So it becomes cos x, is here ax plus b, into d by dx of the thing which we assume as x, that is ax plus b. It becomes cos of ax plus b, into derivative of ax plus b will be a into 1 plus 0. See, when constant is there alone, the derivative will be 0, but when the constant is there with a variable, it should be taken as a multiple, but not 0. Be careful with this point, and we write this as a into cos of ax plus b. Okay, see the fourth question. It is d by dx of, you have to find out secant of tan of root x. So there are three things. This is a chain. We have to apply the chain twice here. See, first of all, secant x, take this as x. What is the derivative of secant x? Tan x. Sorry, secant x, tan x. It becomes secant x, this is x, into tan x, into d by dx of, what did we assume as x? This thing we assumed as x, so tan root x. Now next step, it becomes secant into tan root x, secant of tan root x, tan of tan root x, into derivative of tan. Again, this is not, we don't know the formula of tan root x, but we know the formula of tan x. Now we assume this thing as x. Derivative of tan x will be secant square x. It becomes secant square root x, because this is x here, into d by dx. So what we assume as x? Root x. Now it becomes secant of tan root x into tan of tan root x into secant square root x into derivative of root x is 1 by 2 root x. Don't cancel these two because this is inside the function. We are not supposed to cancel this. We should leave like this. Okay. Now this looks like as u by v. Let us apply u by v. And this we take sine of x and cos of some y. Let us see. First I will write the formula of u by v. V square v d by dx of u minus u d by dx of v. Okay, now it becomes, what is v here? So cos square cx plus d. Now v, cos of cx plus d into d by dx of sine of ax plus b minus sine of ax plus b, u, sine of ax plus b into d by dx of cos of cx plus d. Now what we do? The denominator will not change. It becomes cos square of cx plus t. Now it becomes cos of cx plus t. Now derivative of sine. We know the derivative of sine x. So it becomes cos x. Here this is x. So we have to apply chain rule here. So derivative of sine x, it becomes cos x. Cos x. X is this. Into d by dx of ax plus b. Minus sine of ax plus b. Into derivative of cos is minus sine of cx plus t. Into d by dx of cx plus d. Because we assume this thing as x here. Now, the last step we can take. The denominator will not change. Cos square cx plus t. It becomes cos ax plus b, and here it becomes a into 1 plus 0. I am writing directly a. Because when you take the derivative of ax, a into 1 plus 0. So I write that a first. Cos cx plus t. Cos ax plus b. And this minus of minus plus, it becomes plus sin ax plus b. So better write c first. The derivative of cx plus t is c into 1 plus 0. Write c sin cx plus t into sin ax plus b. Just leave like that. That's all. Okay. Okay. This it looks like uv root. So we take this thing uv. So u d by dx of v plus v d by dx of u. Okay, it becomes cos x cube into d by dx of sin square x power 5 plus sin square x power 5 into d by dx of cos x cube. It becomes cos x cube. Be careful when you are taking the derivative of sin square. We don't have any formula for sin square, derivative of sin square x also. So what we have to do, be very careful here. We have to take d by dx of sin x power 5 whole square we have to take. When you have sin square, it means that sin theta whole square. Okay. And here sin square x power 5, no problem, because the cube is for only x. Derivative of cos x, treat this as x here, minus sin x cube into d by dx of x cube. Why I didn't take here? Because it is the square is for sin here. So I took it for whole square. Now we assume the whole thing as x here. We assume this whole thing. It becomes cos x cube. It looks like x square. Derivative of x square will be 2x. What is x here? Sin x power 5. So 2 sin x power 5 into d by dx. So what is your x here? Sin x power 5. Now this becomes plus into minus sin square x power 5 sin x cube, and this is 3x square. Now look here again. It becomes 2 cos x cube sin x power 5, and derivative of sin x power 5 becomes cos x power 5 into d by dx of x power 5, because we take this as x here. Chain rule. This is chain rule. So minus, whenever you have something like this, you write that front. 3x square sin square x power 5 sin x cube. Now the last step, the derivative of x power 5 will be 5x power 4 into 2. So it becomes 10x power 4 cos x cube sin x power 5 cos x power 5 minus 3x square sin square x power 5 into sin x cube. We should be very careful when we do these problems. See the seventh question, d by dx of 2 root. So 2 is a constant, let us write outside. D by dx, so we take root of cot x square. We don't know such formula, but we know the derivative of root x. Derivative of root x is 1 by 2 root x. So I assume the inside value as x. It will be 1 by 2 root x. X is this. Into d by dx of the thing which we assume as x. We assume cot x square as x. Now, this gets cancelled. 1 by root of cot x square into derivative cot of something, cot theta. So treat this as x, cot x. The derivative of cot x will be minus cosecant square x minus cosecant square. Here x is x square into d by dx. So what did we assume as x? X square. Now it becomes minus cosecant square x square by root of cot x square into 2x. You can leave like that. In the same way, 8th problem, d by dx of cos of root x. Cos of root x will be, assume this as x, it becomes minus sine root x into d by dx of the thing which we assume as x, that is root x. So it becomes minus sine root x into derivative of this is 1 by 2 root x. It becomes minus sine root x by 2 root x. Okay. See, in the ninth question we are asked to check the differentiability at x equal to 1. At x equal to 1. So what we do? So modulus, whenever we have a modulus no function, when you release modulus, it becomes plus or minus. So once it becomes x minus 1, once it becomes minus of x minus 1, that is 1 minus x. So when it becomes this and when it becomes this, I tell you, fx equal to x minus 1 for values of x greater than 1, fx equal to 1 minus x for values of x less than 1. That is left limit of 1 and right limit of 1. Sir, why sir? Why should we write like that? I tell you. So modulus means is a positive value. That should be positive always. So we have to check where these values are positive. See, for x greater than 1, whatever value you take, 2, 3, 4, this will be positive. See, for x less than 1, this will be positive. See, if you take a value x less than 1 here, it will be negative. 0, 2, 0, minus 1, minus 2 like that. If you take, it will be negative. See, that means when mod x is split into two terms, so two functions, then we should see that both the functions are positive. But we should take the interval where it is positive. See, for x less than 1, this is positive. For x greater than 1, this is. See, if you take any value less than 1, 0, minus 1, this will be positive. Now, f dash of 1 minus means just differentiate this one. So, derivative of x is 1 minus 0, it is 1. And here, f of x is 0 minus 1. That means this is 1, so this is minus and this is plus. See, right derivative is not equal to left derivative. So, it is not differentiable. Okay. In the last question also, what did they say? Fx equal to step x. Fx equal to step x actually. For x values 0 less than x less than 3. See, I told you already, step x lies like this. 0, 1, 2, 3, like this. That means it is not continuous, it is breaking here. Breaking at integers. That means when the function is not continuous, no doubt it is not differentiable. And you are asked to check at integers. At integers, exactly the function gets break. The function becomes discontinuous. So, the integers between 0 to 3 are 1 and 2. And at 1 and 2, the function is discontinuous. Therefore, the function, if the function is discontinuous, no doubt it won't be differentiable. So, it won't be differentiable. You can write like that. Alright.